Hello students, good time to all. I am Chandan Kumar Pradhan. Welcome to the channel Chandan Physics. In this video, we are going to discuss nature of nuclear force and NZ graph. Let's begin. Nature of nuclear force. What is nuclear force? Since stable nuclei exist, atom, there will be nucleus. In that of nucleus there are proton and neutrons. So we see the nucleus is exist in an atom. It follows that there must be certain forces acting between their nucleons. In that of nucleus, it has proton and a neutron. Proton positively charged, neutron chargeless. So proton we see electrostatic force of repulsion, but that nuclei exist. How? There must be a strong force which overcome that electrostatic force of repulsion, and that force we called nuclear force. There must be certain forces acting between their nucleons that bind them into the nucleus. These are called nuclear forces. So nuclear forces are those forces which bind the nucleons, the combination of neutron and proton within that of nucleus. The nuclear force must be strongly attractive in order to overcome the electrostatic repulsion between the protons. Only three kinds of attractive forces can be conceived in that of nucleus. Either it is in neutron or neutron proton or proton proton. Let us come to our analysis. If we consider that be nucleus of an atom, in that of nucleus there are proton, and neutron. These are protons, that are neutrons. Overall we call it as nucleons. In this, either proton are interacted with protons, or protons with neutrons, or neutron with neutrons. Either neutron proton or proton proton interactions are there within that of nucleus. As the interaction in between proton and proton is positively charged, positive repelled with each other, and that type of repulsive force due to that electrostatic repulsion. But we see that the nucleus is exist. Why? There must be a strong force which combines these nucleons within that of nucleus. that the strong force is so strong as comparison to that of electrostatic force of repulsion. Okay, that force we called nuclear force. Nuclear forces which binds the nucleons within that of nucleus. So, what be the properties of such type of force? Properties. In the previous video lectures, when we studied about the size of the nucleus, mathematically we say or theoretical evidence confirmed the nuclear size is of the order of 10 to the power minus 15 meter. So, it is a very small area or small region. The nucleus, which is very tiny portion of that of atom, and that size is around 10 to the power minus 15 meter range. It is a small range, small distance. So, nuclear force is that force which acted in that of small range. So, we categorize it as small range force. Nuclear forces are effective only at short ranges. At short ranges, one of the property of nuclear force, it is short range. Let me understand it. If we take an proton and a proton, so these two are repelled with each other due to the electrostatic force of repulsion, that is electrostatic force of repulsion, and that electrostatic force of repulsion acted when these protons are at long range. Let us understand like that. These protons, the distance between these protons are above that of 10 to the power minus 15 meter. If these protons are very close to each other, when the distance in between these two is 10 to the power minus 15 meter, then at that section we see the nuclear force. Above that, electrostatic force of repulsion, but when these two protons within that of small distance range, that is 10 to the power minus 15 meter, then a huge force combine these protons, which is called the nuclear force. So, the range of that force is short range. Next property of nuclear force, nuclear forces are charge independent. Are charge independent. That nuclear force is strongly attractive. That is strongly attractive for proton, that is strongly attractive for neutron, as well as strongly attractive for proton-proton interaction, proton neutron interaction and neutron neutron interaction. So, we can say the nuclear force acting these particles are same. These forces are charge independent. Next property, nuclear forces are the strongest known forces in nature. In nature, we see the fundamental forces like gravitational forces. Here is Coulomb force, that is electrostatic force. When we compare nuclear forces with such type of forces, this one is the strongest. No force is much more to that of nuclear force. Nuclear force is the highest, so strong when you compare it to the known forces till now. Next property of nuclear force, these forces have a Saussure property. Nuclear forces are saturate property. So, what is saturate property? Since we say that nuclear forces acted in that of short range, if the nucleus of another atom are to that of nucleus, or we can say in that of range, so it affects to this, otherwise it does not affect to it. Therefore, we call it as saturate property. Nuclear force are effective only short range, it is a short range force, charge independent, strongest force, and it follow the saturate property since it acted within that of short range. These are some basic points on that of nature of nuclear forces. What is nuclear force and its nature? Next, NZ graph. N stands for number of neutrons and Z, that is the atomic number, which is the number of protons. NZ graph basically used to detect the stability of nucleus. Stability of nucleus is studied with the help of that graph. What is stability of a nucleus? Stability of nucleus depends on how many number of neutrons and protons are in the nucleus of an atom. In an atom, it has nucleus. Within that of nucleus, there are proton and neutron. So, how many number of protons and neutrons are there? On that basis, that stability of nucleus is detected. To study the stability of the nucleus, there are so many methods. There are so many methods to show the stable nuclei. From this, neutron to proton ratio, how much number of neutrons and protons are there in that of nucleus of a particular atom. On that basis, we study the stability of the nucleus. Neutron to proton ratio is one of them, and it can be easily understood with the help of NZ graph. In that of scenario, N stands for number of neutrons, Z, that is the atomic number, or we call it as, that is the number of protons. When we plot a graph, on x axis we taken the number of protons Z, along x axis, that is number of protons, and N along y direction, that is the number of neutrons, (20, 40, 60, 80, 20, 40, 60, 80. These are the number of protons, means the atomic number. See the number of neutrons, atomic number is same as that of number of protons. When we plot that graph, we see this is the straight line, whereas N is equal to Z. This is N is equal to Z line. Number of proton is equal to number of neutron in that of line. In our experimental observation, up to 20, this is up to 20, the number of a proton is same as that of number of neutrons. In that of periodic table, when we see these atoms and we notice that the proton number to that of neutron number, so the number of neutrons is same as to that of number of protons. After that 20 serial, we see the number of neutrons are increasing, and the graph we see just tilted to that of N, number of neutron axis. And that line we called stability line. This line is called stability line. When N is equal to Z, that is 20, it is straight. When N or Z greater than 20, the neutron number gradually increasing and the graph tilted towards in that is y axis. And when we plotted that same graph, and we see a range we see a region, that is the region of stability. The atoms within that of region of stability are stable. The atoms are within this region of stability are stable, and those are below or above are unstable. It is based on their neutron proton ratio, neutron proton ratio. On that basis we categorized it. They try to be stable. These are try to be stable by alpha decay or beta decay. Those unstable nuclei, those are either above or below that of stability region. We called these are unstable, and these atoms, those are unstable. They try to be stable by decaying. Above Z is greater than 83. After that, all the atoms are unstable, and they are show the decay process. On that basis of NZ graph, which basically denotes the stability of a nucleus, that is the neutron to proton ratio, we see how the stability of these atoms are categorized. Up to 20, we see above that 20 the number of neutrons are increased, that is the stability line. If we analyze for a optimum value of that neutron to proton ratio, under that of graph we see a region where the atoms present in that of stability region are stable, either above that or below that are called unstable nuclei. These are transformed to the stable form by decay process, and above that atomic number 83, all the nuclei we see are unstable. So, here with the help of this visual lecture we understand the concept of nature of nuclear forces, what is nuclear force and its properties, or we call nature, stability of the nucleus by using NZ graph. So, with this useful and informative notes, let me wind up the session. Thank you.